Once again, you should be on your kinematics notebook. This notebook is going to be a way to just keep ourselves more organized and for me to not give you so many different assignments and handouts because I know it gets very overwhelming at times, especially when I post new handouts each week. So now everything's going to be in just one digital notebook, and then I'll keep updating it for you guys, okay? So that's just easier for all of us, okay? Less clutter. That's always good. Please go to the 5th slide. Slide number 5. Please go to slide number 5. Okay. Please go to slide number 5. Okay. And it seems that someone just came in. Yes, I'm just messaging you right now. Awesome. Now, slide number 5 basically has the Zoom expectations, okay? So it has Zoom expectations. It hasn't changed, okay? The only thing that I added, and let me share my screen real quick, is this right here. If you need to step away, that's okay. I understand. Restroom, a snack break, water, it's okay. Give me this icon though. Please use the little coffee mug in case you need to step away. That way I know not to call on you, okay? Because if you don't have it and I call on you and you don't respond, I may potentially kick you out, okay? Because you're not paying attention. Okay, so just to test this out, can you please use your manage participants tab and then give me that coffee mug. There you go, that coffee mug break, just so I know you guys know how to use it. Awesome. We're going to be in slide 6 now. Okay. Now, slide 6. Slide 6, I just have some 3 roles, and that's the core value points tracker, the co-host, and the timekeeper. Maybe the point tracker is going to be a little bit too much, so I don't think I'm going to do that after all. But the co-host is basically the person that's been doing it for so long, the person who basically just keeps track of letting people in and bringing back in case they get kicked out. And then the timekeeper, your job is to let me know when there's 5 minutes left in the clock. So if you're my timekeeper at 10:31, you will let me know that we have 5 minutes left, okay? Just so we can start wrapping it up. So during this time, would anyone like to be my co-host or my timekeeper? Awesome. So we're on slide 8. If you can't see your slides because they're very small, just go to the top left, go to view, and then go to zoom, and you can actually magnify it and make it bigger. Okay, that's a pretty cool trick. View and then zoom will make slides bigger. Okay? Because I think for most of you guys, I think it looks like this. And for me, it looks kind of good, but maybe in your Chromebook, it looks a little bit different. Okay, so just go to view, zoom, and then whatever you need to do. Okay. But I'm going to stop sharing and hope that you guys are there. Okay. So this is the layout for this week. Today and tomorrow, we got Zoom classes. And then we got the objectives right here, just 2 objectives. And then Wednesday and Thursday and Friday have their own schedule. So this is the schedule for this week. And every single week on this purple tab, I will keep updating how the week looks, okay? Just so you know what to expect, okay? Just so you know what to expect, okay? So you can check that out. Any questions on what's gonna happen this week? With that being said, let's go to slide 11 now, okay? Slide 11. Please give me a thumbs up or a check mark. Once you're on slide 11, it looks like this. It looks like this. The same layout as our handouts. Let's spend 5 minutes reading the do now and then filling in the table, okay? 5 minutes, read the do now and fill in the table, okay? We're gonna spend 5 minutes on that. 5 minutes starts, Here's slide 11 with the do now. We just finished doing the do now, and here are some of the words right there. Give you guys a couple more seconds to just finish copying that down, okay? Awesome, awesome. So now we're going to go from slide 11 to slide 12. This is how it should look. It looks like this. And we're going to start our notes right here, okay? This is where I'm going to, you're going to follow along from what I say, okay? So we're going to be on slide 7. Started. I'm going to put 7 minutes on the clock, and whatever I type, just follow along.
So here's my 7 minutes. So we've gone over some stuff, right? We've gone over vectors, scalar, and resultant vectors a couple of weeks ago, and it's a pretty easy refresher. But let's actually go over what distance and displacement is. So on that first box, put distance on it, okay? Distance. That's the first one we're going to go over. Now, distance is measured in meters because it's obviously distance, and we're using the metric system. And so solid lines is how we're going to be able to describe them when we draw them. And an example of distance is 21 blocks, okay? Now, what is distance? Distance on that second box to the right is the total travel, total length travel. An object, okay? You already know the definition for that one, right? So it's the total length traveled in an object. That is what distance is, okay? Now, right below it, right below distance, there's another box. I want you to write displacement. And what is displacement? Displacement, right? So displacement is, let me get the correct definition because I want to trip you guys up, is the change in position from start to end point. Okay. Let me change the color of this so you can actually see it better. Is the change in position from start to end point, okay? So displacement is how much did I change in my position. In other words, is the shortest path from start to finish, right? The shortest path. It's also measured in meters, but it also has direction. Okay. Example, 3 blocks east. So the difference between distance and displacement is that distance has no direction, but displacement does have direction. Okay. And there's an example on the top right. My solid line is distance, and my dotted lines are my displacement, okay? Now, there's a table right here. All measurements fall into 2 categories, and those categories are scalar and vector. Just a quick refresher for what scalar and vector are, okay? Scalar only has magnitude, but just like Caleb said, and then vectors have magnitude and direction, okay? Kind of what Jonathan said, okay? Now, an example of scalar is distance. An example of vector is displacement, okay? So distance is a scalar measurement, and displacement is a vector measurement. So remember that, okay? Scalar and distance go together, and vector and displacement go together, okay? But obviously, you guys would like to see an example, right? So we're looking at an example right here. Example 1, a physics student walks 3 tiles east, 2 tiles south, 3 tiles east, and 2 tiles north. I drew my little diagram of that. So 3 tiles east, 2 south, 3 east, and 2 north. What's my distance? So what's my total length traveled? Well, I traveled 3 tiles east plus 2 tiles south plus 3 tiles east plus 2 tiles north, and that equals to 10 tiles total. Okay? That means I traveled 10 tiles in total. That was my distance, my total distance traveled, okay? Now, what's my displacement? My displacement is the difference, the change in position from my starting point to my ending point. So if I started right here at the very left and I ended up on the very right, I put like a little dotted line. So that means I just literally went a straight line, right? A straight line. So my displacement is the shortcut, the shortest distance. And if you add all these together, it's that 3 and that 3 on the bottom. So actually, my displacement is 6 tiles. Because if I just go in the straight line, that's going to be 6 tiles in total. Okay? You can even count it. 1, 2, 3, 4, 5, 6. So my distance was 10 tiles. I traveled 10 tiles in total. But my displacement was 6 tiles. That means the shortest distance was 6 tiles from the starting point to the ending point. From start to end. And the only thing I'm missing, which I forgot to write down, I'm missing my direction. So 6 tiles east, okay? 6 tiles east. Because I forgot that displacement is a vector and vectors need direction. So not only is it 6 tiles, it's 6 tiles east, okay? I traveled 6 tiles east for my displacement. So don't forget that east part, that distance, that direction is important, okay? Awesome. We're going to be on slide 18, okay? Now, slide 18 are just examples. So in case you ever need some extra examples, make it a little bigger. Some extra examples, they're right here. So example 2 and example 3, in case you want to know it. Here, let's look at example 3 real quick. Look at example 3. A runner runs a lap around a 400-meter track before stopping where she started. So if it's 400 meters, she made a whole lap around. She traveled a distance of 400 meters, right? Because it's a 400-meter dash, right? For any of my runners out there. But why is the displacement 0, though? Can anyone tell me why the displacement is 0? Is the displacement the resultant vector? And yes, the displacement is literally the resultant vector. Because the resultant vector is what? The resultant vector is the shortest distance, right? So yeah, good job. I'm actually going to highlight Ariel. Shout out to Ariel. Yes, the displacement is the resultant vector. Good job. But does anyone know why the displacement is 0? Okay, it doesn't seem like anyone knows why displacement is 0. Remember, displacement is what? Displacement is the difference between your starting point and your ending point. If you made a whole lap around and you started at the starting line and you made a whole lap and then you crossed the starting line again, that means your displacement is 0 because you finished where you started. So even though the total distance is 400 meters, your displacement is 0 because you didn't move, technically you didn't move from your starting point. You started and you ended in the same place. You started and you ended in the same place, okay? Okay, with that being said, let's go to slide 21. This is the last thing we're doing. Slide 21. Your screen should look like mine. Please give me a thumbs up or a check mark if you are on slide 21. Let me just erase these values because these values are not important right now. And I'm going to set a timer on the screen right here. And when I say go, you're going to walk to the destination that I tell you. So right here, we have 3 destinations. We have kitchen, we have bathroom, and we have the front door. Okay? So I want you to walk. In this case, we're using each step you take as 1 meter. So when you take 1 step, that equals to 1 meter. Okay? Now, this is what we have to do. Let's say, for example, we head to the kitchen. When you head to the kitchen, count your steps Some people are at school, and that's okay. If you're at school, you can't do that, then I'm just going to write down the data for you, okay? So don't worry about that. So when heading to the destination, count the steps you have taken until you get to that destination, then stop counting. So that means when you walk to the kitchen, count your steps, 1, 2, 3, 4, 5, 6, 7, 8. Let's say it takes you 10 steps to get to the kitchen. Once you get to the kitchen, stop counting, okay? Once you get to the kitchen, stop counting, and then just walk back to where you were at with your Chromebook, and then look at the timer and record the time right here, okay? Once again, you're going to walk, when I say go, you're gonna walk to the kitchen, in this case. You're gonna count your steps. Once you get to the kitchen, you stop counting. Do not count anymore. And then just walk back and sit back down. And then once you get back to your Chromebook, once you see my screen again, check the time. And once you check the time, I want you to record it where it says time right there, okay? Let me give you an example. I said, okay, go. I'm walking to my kitchen. 1, 2, 3, 4, 5. It takes 5 steps to get to the kitchen. I stop counting. I walk back. I sit back down, and I see that the time was, let's say, 10 seconds. So I'll put 10 seconds right there, okay? Any questions before we get started? Awesome. So let's actually look at our data. Let's use Yesenia, for example. World record, yes. Yesenia, it took you 16 steps to get to the kitchen, and it took you all of 23 seconds, right? 23 seconds to come back. Now, even though it took you 16 steps to get to the kitchen, what was the total distance you traveled, right? If one step is 1 meter, so 16 steps is 16 meters. So if it took you 16 meters to get to the kitchen, what's the total distance you traveled? Well, you went from your Chromebook to the kitchen and then back to the Chromebook, right? So you actually traveled not 16, but 32. Remember, it's from your starting point to your ending point. So even though you traveled 16 meters to the kitchen, you also traveled 16 meters back with a total of 32 meters traveled. That means, Jasmine, you took 22 steps, so you actually took 44 steps to come back. So you traveled 44 steps. Juan, you traveled 34 steps because it took you 17 steps to get to the kitchen and back, okay? And displacement, what is displacement? Well, displacement is the difference between your starting and your ending point. So what do you think we're gonna put for displacement here? Let's do one more. Let's do the front door of your house, okay? The front door of your house, okay? I hope you guys are ready. The time, go to your front door. Time starts now. Go to your front door. Once you come back, record the time. Once again, once you get to your front door, record the time. Once you come back. Yesenia, 16 steps in 20 seconds. Love it. Okay. Let's use Caleb's for this time. So let's check the front door. Caleb, it took you 15 meters to get to the front door. But what was the total distance you traveled? Well, let's multiply that times 2 because it took you 15 steps to go to the front door and 15 steps back. So about 30 meters. So Caleb traveled 30 meters in total. How long did it take him? It took him 30 seconds. And what's the displacement? Displacement is what? Well, he didn't change position, right? He started and ended in the same place. So his displacement is 0 meters. Okay? And that's basically what you guys are doing today. So this will be homework because I would like for you guys to see this tomorrow for you guys. So for your homework, all you gotta do is just do 2 more trials for kitchen, do 3 trials for bathroom, and then 2 more trials for the front door. Okay? That is your homework. That is all you're doing for today. So just fill in the table because tomorrow we're gonna analyze it. Okay? The homework is just to fill in the table on slide 21 for today.